So here, oh geez, I made that a bit too big. R1's remote network would be the blue ones, the networks outlined in the blue circle, while its connected networks would be the ones outlined in the red circle. Okay, so it's connected to 1.1.1.0 and 192.168.12.0. Yeah, and you can see 192.168.12.1 is assigned to that interface there. So therefore it's connected to that network. Yeah, so it's not going to know about R2's network or R3's networks. And so you can either configure loads and loads of static routes, and this wouldn't be a lot of static routes, but if you had a large network with 50 routers, then you're going to look at a lot of static routes, which is not scalable, it's not feasible, it's a lot of administrative overhead, and anything with administrative overhead will lead to administrative mistakes because humans make mistakes. Computing devices don't make mistakes, they just do what they're programmed to do. Okay, so we need a dynamic routing protocol. And I said yesterday, a dynamic routing protocol, is used to discover remote networks. And the definition of a remote network is a network that is not directly connected to the router. Yeah, so R1's remote networks will be in blue here. Okay, now you have RIP and you have OSPF and you have EIGRP, and the one for the CCNA is OSPF. So what happens with OSPF? How does OSPF essentially work? Well, if you think about it, in order for R1, let me just close this out a bit again. Actually, leave it on. In order for R1 to discover the blue networks, it will have to learn about those networks from R2, because R1 is not going to know about this network here, for example, 192.168.3.0. It can't possibly know about that network unless R2 tells it. So what will happen is R1 and R2 have to create an OSPF special connection, a special connection that they will have. It's like a bond with each other, okay, and it's called an OSPF neighbor relationship. And you create it by R1 or R2. First of all, you have to be able to see each other. R1 has to be able to see R2. It has to be able to ping it. If it can't ping it, they're not going to be OSPF neighbors. Like, so you have to, obviously there has to be IP address details. There has to be layer 1, layer 2, layer 3 information set up in order for R1 to become OSPF neighbors with R2. So what you do is you turn on OSPF on the interfaces that you want participating in OSPF. So let's go into R1 here. You turn it on here, and when you turn it on, R1 will start sending these hello messages. Okay, it's sort of like trying to discover another network. Now it doesn't send it to R2, it sends it to, well, it sends it to R2, but it sends it to a special multicast address of 224.0.0.5. This is a reserved multicast address that only routers running OSPF will listen in on. They'll only accept information. If you're a router and you're not turned on OSPF, well, then you're just going to discard any packets coming into 224.0.0.5. Okay, so it's not just, in order for R1 to become neighbors with R2, it has to be able to send OSPF hello messages to R2, but then it has to receive OSPF hello messages from R2. Okay, so it's a two-way thing. R1 has to send a hello to R2. R2 has to send a hello back to R1. Okay, and we've seen that yesterday. Some of the things that are included in the hello messages are the router ID, which is unique to the router. Okay, so basically, It's how the router identifies itself within this OSPF map. We talked about yesterday. The next step, first step is they will become OSPF neighbors. The next step after that is they will use their neighbors to create a map. Okay, so for example, R1 will have a router ID of its highest IP address. So let's say we have a loopback here of 1.1.1.1. Well, then that's going to be R1's router ID. If R2 has a loopback address of 2.2.2.2, well, then that would be R2's router ID. The router ID has to be unique. You can't have R1 and R2 having the same loopback. Excuse me. Excuse me. What would happen if you did? What would happen if R1 said, hi, I'm 1111, and R2 said, hi, I'm 1111? What would happen? They wouldn't become OSPF neighbors. Okay? If they're not becoming neighbors, then nothing else is going to happen. Okay, so the start of this all is the two routers become OSPF neighbors. Nothing else is going to happen unless they become neighbors. Okay. And we talked about this yesterday, is that by default, the highest IP address of a router's interface is chosen to be the router ID. However, loopbacks are preferred over physical interfaces. So you can see here, router R1 has 4 interfaces, but it's going to prefer, 12.0.0.1 to the other connections because that's the loopback address. Okay. Also, this hello message is an envelope containing information that is sent every 10 seconds. So part of the information you're going to have what's known as the hello and dead timers. The hello timers is every 10 seconds. The dead timer is 40 seconds. So R1 is sending hello messages, hello, 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 every 10 seconds. R2 receives a hello message from R1. It counts down its dead timer. It counts down from 40 seconds. It will only go as far as 30 seconds, 30 seconds, before it gets another hello message from R1, because R1 is sending hello messages every 10 seconds. Okay, other things that are included in the hello and the hello message is the subnet mask of the interface. So typically your point-to-point connections have a /30 subnet mask, which is 255.255.255.252. Also, you have your area ID, which is area 0. It's in dotted decimal format, which is 0.0.0.0. And we've seen that yesterday. Any questions on that? Okay.
No, I would.
Okay, cheers, thanks, right. So that's the first step. Nothing else will happen until the routers become neighbors. Okay, so when the routers become neighbors, we turn it on. So let's say we have R1 and R2. Actually, I'll just remove. I think I've done this yesterday as well. Kind of just this one here is kind of in the way a little bit. So you have R1 here and R2. Okay, they're neighbors. Okay, let's assume they're OSPF neighbors. They have established an OSPF neighbor adjacency. Now, you might be saying, hey, you're spelling neighbor wrong, but this is CISCO, and CISCO is an American company, so it'll be NEIGHBOR. So your commands, show CDP neighbors, show IP OSPF neighbors, show BGP neighbors is BORS. Okay. So OSPF neighbors between R1 and R2. The next thing what will happen is it's a dynamic routing protocol. So R1 has to send information across to R2. So it will send what's known as a link state information or link state advertisement across. So let's say R1 has a network down over here of 192.168.1.0. R1 will send that, and it's just a small piece of information containing information about its network to R2. R2 will update its link state database with information about that network. So let's say 192.168.1.0. Say, oh, that's great. Thank you for telling me about that network. R1, I didn't know that, and I'll put that into my link state database. And if R2 has a network, it will send that information across to R1. Okay, so what will happen is they will check to make sure that their link state databases are the same, that their maps are the same. Once their link state databases are the same and are in sync, then they will look. So essentially the map is built. Okay, think of it as a map. No, that's way too big. Okay, this is the map. So what changes it here and then? Let me just show you. Snippet. So this is your map here, okay? So let's say you have got Dublin, Cork, Galway. So Dublin is here. Oh, that's not a good color to use. Black might be better. Dublin, Cork, Galway, Belfast. Yeah, and Limerick. So once the map is built, then the routers will know where all the other routers are. So the map will be the same, but what's going to be different? The ways of getting there is going to be different. For example, Dublin is going to go a different way to Belfast than, let's say, Galway. Their neighbors are going to be different. Dublin's neighbors are Belfast and Cork. Cork's neighbors is Limerick and Dublin. Galway's neighbors is Limerick and Belfast. So their neighbors are different, but their maps are the same. So the map will be the same. The routes will be different. And their neighbors will be different. That makes sense? Okay. Close out there. So what we'll do is we'll have a look here at an OSPF network. So I want you to go into your Dropbox connection and download this network here. Okay, so it's under CCNA material OSPF. I think one of the lads, actually, let me just go in here, just bring it up. I'm just getting the little Dropbox link here. There we go. Okay. So you have CCNA material, slides and labs, day 8, OSPF labs, and you're looking for network with 5 routers and IP addressing. Okay, let me know when everyone has that. So open that up and you'll have Dublin, Cork, Galway, Sligo, and Belfast. And we can figure this together. Thanks, John.
Have it.
Thanks, Graham. Stuff, Gary. Okay, so what we're going to do is we're going to turn on OSPF on all of these routers. We're going to turn it on in Dublin, and Cork, and Galway, and Sligo, and Belfast. They're going to become neighbours with each other. I'm going to do a few things with it. Okay, am I still waiting on anyone? Has everyone have their packet tracer up and running there?
Yeah, all good.
Okay, good. It's good stuff. Anyone not? Okay, all right. So you go in, you can see their IP address details are there. So we'll go into the first router, Dublin. Now what I'm going to do is, you can't see it here, but Dublin is going to be using the address of enable fixed base T, exit. I'll do show IP and brief first. Okay, so we're going to create a loopback address. Dublin is going to be 1111. Cork will be 2222. Galway will be 3333. Sligo will be 4444. Belfast will be 5555. Okay, let me just annotate that in there so we can see it. Draw. Okay, so Dublin is going to be 1111. Cork will be 2222. Galway 3333. Sligo 4444. And Belfast 5555. Okay. And then we're going to turn on OSPF. So do not, the first thing what you want to do is you need to create your loopbacks before you turn on OSPF. Okay, if I went in here and I turned on OSPF as is, if I went in here, fixed base T, and I turned on OSPF on this WAN interface, IP OS, so what will happen is OSPF will look at its interfaces there, and because there's no loopback, it will pick its router ID of one of these two. If I go and create a loopback address after, it's too late. It has to be in place. The loopback address has to be in situ before you enable OSPF. Does that make sense? Okay.
Yep.
So I only want you to turn on OSPF on the WAN interfaces. Don't do FA0/0 and FA0. Don't do this one here in Dublin, and don't do that one in Belfast. Okay. I thought we'll do that in a minute. So don't do this one here, and don't do this one here. Do the WAN interfaces first. Okay, so you go into Dublin, interface FA0/1, IP OSPF 1, area 0. Very, very simple. Actually, what I just, 1 second. I'm after telling you not to do something, and I went and done the same thing. Clear IP OSPF process. Okay, so config space T, first thing, create a loopback. Interface loopback 0. IP address 1.1.1.1, 255, 255, 255, 255. Loopback is done. Exit. Then interface FA0/1, IP OSPF1, area 0. That's it. Do that for Dublin, Cork, Galway, Sligo, and Belfast. I will put up the link. I'll put up the commands here now in a second. Now you have to do it for all of its relevant interfaces. But let's just figure it out yourselves. It's easier then. It kind of just gives you something to think about doing it rather than just blindly copying it off what I'm doing here. So this is the commands for Dublin. You need to change it to suit the other sites. Any questions at all, let me know. I've no problem helping you out. Okay, so obviously for Cork, you're going to have to do it on FA0/0 and FA0/1. Galway, FA0/0, FA0/1. Sligo, FA0/0, FA1/0. And Belfast, FA0/0. Okay. Let me know when you're finished, and we'll discuss it. IP address 2.2.2.2 space 255, 255, 255, 255. Interface FA0/0, IP OSPF1, area 0. Interface FA0/1, IP OSPF1, area 0. Done. Okay, go into Galway. Do the same thing. Enable. Interface loopback 0, IP address 3333 255 255 255 255. Interface FA0/0. You don't even have to exit. You can just go in and interface FA0/0, and that will switch from your loopback address to your FA0/0. IP OSPF1 area 0. What I'll do is I'm just going to copy that. Same as typing all the time. Exit int FA0/1. Enter. There we go. Always see a neighbor adjacency already with Galway, with Cork. Okay, Galway's done. Went to Sligo. Enter. Enable. P interface loopback 0. IP address 4.4.4.4 255 255 255 255. Interface Sligo has FA0/0. And interface FA1/0. And then Belfast. Okay. Enable config space T. Interface loopback 0. IP address 5555 255 255 255. Interface FA0/0. Paste IP OSPF1 area 0. Okay. Cool. Is that okay? Any questions on any of that? So now to verify it, we can just go into Dublin, enable, and do a show IP route. To filter our OSPF networks, show IP route OSPF. And you can see here, Dublin knows the routes that Dublin learned from OSPF is 4.0, 6.0, 8.0. 4.0, 6.0, and 8.0, all /30s. Like I said here, this is a little bit confusing, okay? So how Dublin learned about 4.0, let me just, which is basically this network here. Okay, how Dublin learned about that network is it learned about that network from OSPF. The O stands for OSPF. The 110 is the administrative distance for OSPF. So we looked at that yesterday. So the administrative distance is what the routers use to say, who do I trust the most? So if we had RIP coming in and saying it believed it had a better way of getting to 192.168.4.0 than OSPF, RIP's administrative distance is 120. OSPF's administrative distance is 110. So therefore, the route learned from OSPF will be preferred because 110 is lower than 120. The 2 here is not the hop count. The 2 here is the cost that Dublin will use to get to 4.0. How does it calculate the cost? Well, by default, fast Ethernet connections have a cost of 1. Okay, let me just annotate this again. Okay, so Dublin's cost, Dublin is here. To get to here, there's 1 here and 1 here. So that's why it's a cost of 2. So, but like it's only 1 hop to get to this network, but it costs 2. So what happens is Cork says its link has being fast Ethernet has a cost of 1. So FA links has a cost of 1. So 1 and 1 is 2. Okay, does that make sense?
Yep.
So you can see 6.0 the cost of 3 because you have 1 and 1 and 1. It's 3. 8.0 cost of 4. 1 and 1 and 1. Yeah. Okay. And then it has the next hop IP address. If I do, let's look at our link state database. Show IP OSPF database. Okay, this is the map that I said. This is your command here. Put it into chat. Show IP OSPF database. You can see here, this is the map. It's always the same. The routers in the same area will share the same map. This is all area 0. So if I go in here and I use this command in Cork and Galway and Sligo and Belfast, they'll all have the same map. You'll have the link IDs and you'll have the router IDs. Excuse me, let's just turn off this. Okay, any questions on that? Now, actually, you might have something different because no IP OSPF neighbor. Look, yeah. So remember, I made a boo-boo at the start. I configured Dublin as being 1111. I didn't do that at the start, so I created the loopback after. So my neighbor in Dublin isn't 1111, it's 192.168.2.1. You won't have that. If you do it right, unlike me who done it wrong, it should be 1111.222.2333334444555. Let me change. I should be able to change that. Fixed space T. No. Yeah, space 1. Let me just try and change that. Space FA 0.1. No IP OSPF 1 area 0. 8 space FA 0.1. Down. IP in brief. Just doing a couple of things here to stop it. Oh. Okay, let me just see if that makes a difference. Okay, go back in here again. FA 0.1. No. Right. Oh, there we go. It did. Yeah. So now if we go back in here, show IP OSPF database. Oh, it did. That age, that should time out, shouldn't it? 1 second. That database should time out. Yeah, that should time out. Anyway, it doesn't matter. So you can have 1111, 2222, 3333, 4444, and 5555. You have the router IDs there, and then you have the link ID. So this is basically just a map. You don't need to know really anything on how the map works. If you want to do then show IP OSPF neighbors, you can see Dublin here is neighbors with 2222. Now the thing is, we've done this on purpose, is that Dublin, I didn't configure FA0/0. So if I go into Cork here, let me just erase this here. We didn't turn on OSPF here on this interface, FA. We didn't turn it on here, or we didn't turn it on here. So I just wanted to show you the differences between not turning it on. So if I go into Dublin and I do show IP route OSPF, Dublin doesn't know about the 192.168.9.0 because we didn't enable that interface in Belfast. We didn't go into interface FA1/0 and enable it. So therefore, Belfast, because we didn't do it, Belfast didn't create an LSA, a link state advertisement, to be shared with Sligo and Galway and Cork and Dublin. If we turn on, when we turn it on, and we will in a second, the first thing that it'll do is Belfast will send an LSA to Sligo, because Belfast, it can only talk to Sligo, which is a neighbour, and then to Cork, and then to Galway, and then on to Dublin. Okay, so go into Belfast. Enable config space T interface FA1/0 IP OSPF1 area 0. So we're saying I want Belfast participating in OSPF. We want Belfast to create an LSA for the network that is connected to FA1/0, which is 192.168.9.0. And that will happen in behind the scenes. We won't see it happening, but if I go back into Dublin and type in show IP route OSPF, now we have this network here. Okay. Another thing as well, we need to configure FA0/0, because if I go in here onto 1.2 and I try and ping 9.2, is it going to work? Ping 192.168.9.2. What will happen is it's going to time out. Why? Because the packet will go all the way across to Belfast, but the problem is Belfast doesn't know about me. It doesn't know about the 192.168.9.0 because I never enabled this network here. So while this ping will go from Dublin to Belfast, because we all the routers now know about 9.0, the response back will fail because Belfast doesn't know how to get back to Dublin. All right, does that make sense? So we need to turn it in FA0/0 on Dublin as well. Config space T interface FA0/0 IP OSPF1 area 0. Once that's done, then we can go back in and rerun that ping. And that's what you should be getting. You should be getting a response. You should be able to ping 192.168.9.2 from 192.168.1.2. Okay. Have a go there. Let me know how you get on. The end goal.
Yep.
Good stuff.
All good.
Cool. Much better, much easier than doing static routes. Like you have to do a lot of static routes here. Let's hit this.
Do we still have to do the passive interface command on the interfaces that are attached to the LANs?
You can, yeah, you can if you want. I just didn't include it here because there's a few other things I want to talk about. But yeah, you can go into interface FA0/0 and set up passive interface. Yeah. What I want to do is, if possible, let me just see if it is possible. If I have enough interfaces to do this, let me just show you. Crap. Yeah. Second here. I want to check out something here. Just give me 1 second, guys. I'm just going to references. Want to see view. No. Want to set up these two routers here to link up with each other. Ah, okay. Cool. Okay, so we're going into FA0/0 here. Okay, so I'm going to create a router here, Dundalk. Let's see if I can do this real quick here. All right. Enable configure C hostname space Dundalk. Okay, interface. Okay. It does 0, 9.0, 10.0 here. Okay, so interface FA. Oh, I can't breathe. Okay, so FA 0/0, IP address 192.168.10.2, 255, 255, 255, 252. Shut down even. IP OSPF 1 area 0. Okay.
Do you need the loop back?
No, I'm not gonna. I'm just trying to do this real quick. So I probably won't have time to do a loop back. Oh, so IP in brief. I want to try and get this up and running before interface FA 1/0 IP address 192.168.10.1. Did that go up? That go green? Yeah, cool. Okay, so interface FA 1/0 IP OSPF 1 area 0. Okay, that's that connection done, and then we've got another connection between Dublin and Dundalk and Belfast. So show IP in brief. Interface FA 4/0. Address 192.168.11.1. 255, 255, 255, 252. No shut. IP OSPF 1 area 0. So I'm just creating an extra link between Dundalk here and Belfast. That's 11.1, and this will be 11.2. IP in brief. Interface FA 4/0 IP address 192.168.11.2. 255, 252. That should go green. Yeah. And IP OSPF 1 0. Right, okay, this is working. Now basically Dublin's route to get to 192.168.9.0 is not going to go via Cork, Galway, Sligo, Belfast. It's going to go Dublin, Dundalk. Let's have a look in here. So this is Dundalk here. And this network here is 192.168.10.2. Yeah, okay. Okay, so let's have a look. Okay, neighbor is good. It's set up a neighbor. You can see it's using 10.2 because it didn't create a loopback. So we'll do show IP route OSPF, and to get the 9 dot, look at it. So Dublin is saying so IP route 192.168.9. Yeah. Okay. You can see here, Dublin is saying the best way for me to get to 9.0 is via fast Ethernet 1/0 and 10.2. Yeah, which is Dundalk. Okay. So how do we how can we tell? Well, you can do what's known as a trace route. So I can go onto this PC here and do a trace route to 9.2. So trace route, what it does is it's a little bit more advanced than ping. It will show you your layer 3 hops, your router hops that it chooses to go in order to get to Belfast. So trace cert 192.168.9.2. And you can see it's saying, in order for me to get there, I'm going via 1.1, which is the local default gateway. It's going 10.2, it's going 11.2, and 9.2. 1.1, 10.2, 11.2, and 9.2. Let me just see if I can. Can everyone see that? So the path this PC is taking to get to 9.2. It's going 1.1, which is default gateway. Then it's going 10.2, which is the link to Dundalk. Then it's going 11.2, which is the link to Belfast. And then it's going 9.2. Okay. Now, the last thing we're going to do is we want to test out redundancy. So in order, any packets between here and 9.2 is going this way. Hitting 10.2, hitting 11.2, this is 11. This network is 11.2 and it's going across here. Any questions on that? Okay.
Nope.
Let's see this in action. So I'm going to do a ping, and I'm going to say ping space 192.168.8.9.2. Let's see. Okay, and when we're pinging it, and I'm going to go in, and I'm going to shut down this link between Dundalk and Belfast. Okay, I'm going to go in here. So show IP int brief. The link between Dundalk and Belfast is FA4/0. I'm going to bring it down. Backspace T. Interface FA4/0. Put down. It's gone down. You see it going red. Okay. 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 Look, what happened? One missed ping. One missed ping. And now traffic has rerouted between Dublin, Cork, Galway, Sligo, and Belfast. The link has gone down. OSPF found out that the link was gone down. It has a map shown where everywhere else knows about and says, okay, the link has gone down between Dundalk and Belfast. That's fine. I can go via Belfast, Sligo, Cork, Galway, and Dublin instead. So if I do another trace route from this PC, so I'll stop this ping and now do a trace route, what we're going to see is we're going to see 1.1, 2.2, 4.2, 6.2, and 9.2. 2.2, 4.2, 6.2, etc. 1.1, 2.2, 4.2, there. 1.1, 2.2, 4.2, 6.2, 8.2, and 9.2. It's rerouting across. Earlier on, it was going the faster way. Why was it going the faster way there? Why was it going Dublin, Dundalk, Belfast when this link was active? Because it was less cost. It had less cost. If I bring up this link now, no shutdown. Just fast forward that. Okay. And now do a trace route again. Oh, 1 second, it might take a second. Do a trace route again. There we go. 1.1, 10.2, 11.2, 9.2. If I go into Dublin's routing table, you'll see the cost it takes to get to 9.0, show IP route, OSPF, via Belfast, via Dundalk is 3. Yeah, 1, 2, and 3. Whereas the cost it would have taken to get to 9.0 if this link is gone. Let me delete this link. Is going to be much higher. 5. So any questions on that, guys?
Just regarding the cost, obviously, if you're going fast Ethernet or gigabit or 10 gig, does the cost change?
That's a great question. When OSPF was first built, it says fast Ethernet was the business. You couldn't get better than fast Ethernet. So what it did is it said fast Ethernet links have a cost of 1. You're not going to get better than fast Ethernet, okay? And then you have gigabit connections, and then you have 10 gig connections, and now we have 25 gig connections, and now we have 100 gig connections. We've got 100 gig connections at work, 100 gig links. So there is a command you can use to multiply everything by 10 or 100. So if we have 100 gig, let's say if we have gigabit connections, we can multiply everything by 10. So therefore, gigabit connections would be 1. Fast Ethernet connections would be then 10, and so forth. So you can change the costing system to allow for increased speeds in your network. But by default, the costing system is the same for Fast Ethernet. Let me see it here. Have a cost of 1. But you can change that. There is a see the way there is a link. There is an algorithm that it uses to get this. You don't need to know it for the CCNA, but basically it's 10 to the power of 8 divided by the bandwidth in bits per second, which will get you the cost. Does that make sense? Kind of. Let me show you. Let me show you real quick. Calculator. Okay, so let's say it's a T1 link, okay, 1544 megabits per second. So 10 to the power of 8. 10 to the power of 8 is saying, you can go just the standard here. 10 to the power of 8 is this: 10, 1, 2, 3, 4, 5, 6, 7, 8. Okay, 8 zeros. Divided by the bandwidth, 1544 megabits per second. So divided by 1544, that's in megabits, but I want it in bits per second. So I have to add 3 zeros to get it in bits per second. Equals 64. And what it does, it rounds down, not up, down. So the cost of a T1 link, which is 1544 megabits per second, 64. That's how it gets the cost. Everyone's gone quiet on me.
That makes sense.
Good. What I'll do is I'm gonna save this file. I'm gonna put it into Dropbox, and what I'm gonna say is redundant OSPF lab, and just go back over the video again and just do trace routes, shut down links, and you can see OSPF working on it.
Super.
Cool.
Okay, guys.
Thank you.
No problems, guys. Have a good weekend.
Cheers.
Yeah.
Yeah.
See you on
Good
Tuesday.
luck.
Same.
Thank you.
Cheers, lots of luck. Bye-bye.
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 Cheers.
Bye. Bye.
Cheers, Lee.
Thanks, Tony. Cheers, man. Thank you.